Programmers often use macros to create internal DSLs. Some of these DSLs are widely adopted, and their users want to use macros to extend the DSL or abstract over DSL code. That is, programmers want these language extensions to be themselves extensible. Here are a couple examples from the ecosystem of Racket, a macro-extensible programming language. Rash is an interactive shell DSL that mixes Racket code with traditional shell commands. This example uses an extension to Rash, the intemptor macro. The program compiles a text document with output to a temporary directory, which is automatically cleaned up afterwards. And here's a snippet of a parser for an expression language, with several precedence levels. It's written in DSL for parsing expression grammars, or PEGs. It uses a PEG macro called binops to abstract over the parsing logic that's common to each precedence level. We contend that macro-extensible languages should provide explicit support for making macro-extensible DSLs. So what kind of architecture should we use to build these DSLs? And what kind of support do we need from the host language? Here's what we've done in Racket. We use the same architecture to make DSLs extensible as we use to make Racket extensible. We combine a macro expander, a core language, and a compiler. Using a custom expander and compiler means that DSLs can implement any kind of syntax, static semantics, or optimizing compilation. For example, the PEG DSL has a static semantics that rules out left recursive parsers. The PEG DSL compiler implements this with a fixed point analysis. Rather than implement DSL expanders totally from scratch, we can reuse features from Racket's expander. That way we can have the Racket expander and all DSL expanders share a common implementation of essential language-independent concepts, like scope. This sharing enables integration between languages. We've created a new API that exposes the language-independent parts of Racket's expander. Let's take a look at the kind of integration we get in the case of the PEG DSL. Here's a definition of the binops macro we saw used earlier, along with supporting code. PEG DSL code and Racket code are weaved together within one Racket module. There's Racket code defining a data type for the abstract syntax, and a helper function for constructing left-associated ASTs. In the binops macro definition, there's PEG code for parsing, and within the PEG code, there's a semantic action written in Racket. So the binops macro abstracts over code that is written in a mixture of languages. Scopes are shared and bindings cross languages. The Racket expander creates a scope for the module, which contains PEG non-terminal definitions. And the PEG expander creates a scope for the semantic action. The PEG code binds parse variables in the semantic action scope, which are referenced in the Racket action expression. This all works because the PEG and Racket expanders share a module system, as well as the implementation of scope, binding, and macro hygiene.